Okay, welcome back. Now we're into Part B application. Let's take a look at these. We're going to need a calculator for these. Find the amount of an investment, so one investment of $1,540. It's going in at 3% per annum, compounded semi-annually for 10 years. So that's one amount going in, going to stay in there, and it's going to get some interest. So that's going to be compound interest because it's compounded semi-annually. So amount equals present value, or the principal, 1 plus I to the n. In this case, the principal is 1,540. The interest is 3% compounded semi-annually. So that's going to be 3 divided by 100 divided by 2, 0.15, 0.015, sorry. And n is going to be 3 years. Is it 3 years? No, it's 10 years compounded semi-annually. So 10 years, twice a year. That's 20 compounding periods. All we need to do is plug in the numbers. Know how to use your calculator. And it gives us an answer of $2,074.15. Now that little bit is a little bit that I'm owed, but the bank can't give that to me. So unfortunately, they'll say, too bad, so sad, we're going to keep that. So that's 3 marks for that one. Julia wants to have $77,000 to buy furniture when she moves in an apartment 5 years. So this one was moving this way. We had a principal amount that we were investing. We had 10 years go by. And we had interest being given twice a year. So 20 times interest was given, and the rate of interest was 1.5% during each of those times. And it came up to an amount. This one's going the other way. So she wants to have $7,000 at the end of 5 years. That's going to be compounded quarterly. So there's going to be 4 times 5. There's going to be 20 compounding periods, just like there was 20 compounding periods up here. The only difference was it was 10 years times 2. And we want to know how much should she invest now to be able to get that. So the formula is present value equals the amount. And there's 2 ways we can write this formula. The easiest one, I think, is with the negative exponent. And so our amount is going to be what we want to have. So it's $7,000. The interest rate is 6.75 divided by 100. And then we're going to divide that by 4. And we come up plus 1. And I've got 1.016875 to the negative 5 years compounded quarterly, 20. So off to the side you could have included that. A equals 7,000. I was equal to 6.75% divided by 4. And n is 5 years times 4. And finally, using your calculator, do the exponent 20 negative equals times 7,000 equals 50089. Now hold on, I want to see this. How much must she have? So she needs to have 94 cents and a little bit. Well, if she doesn't have that little bit, then she's not going to quite have all the money that she wants. So in this case, we're going to invest that extra little bit of a penny so that she definitely has the $7,000 at the end of the 5 years. That's it. That's all she wrote. This next question, a bit of a mistake on my part leaving it on the test because it's the exact same as the question above it. What's the present value for $5,000 in 8 years, 6% per annum, compounded quarterly? Exact same question, exact same formula. I like using the formula with the negative exponent. So we're going to want to have 5,000. The interest rate is 6% compounded quarterly. So that's 6 divided by 100 divided by 4, 0.15. And your N is going to be, let's see, it's 8 years compounded quarterly. 8 times 4, 32. So our present value is going to be 5,000, bracket 1.015 to the negative 32, using my calculator, plus 1, exponent, 32 negative, equals, times 5,000, and we come up with an answer of $3,104. And again, I'm going to add that little bit of a penny so I'm not short when I go to take my money out. And that's how much I'm going to put in. So there you go. Once again, another present value coming back this way. Okay, guys, that's part B, the first page of part B. We'll be back in a moment.